Okay, one of the questions that you were asked in the SOC lab was to look at these six motion graphs, position time graphs, and rank the distance traveled from the beginning of each function to the dot on each function. So the beginning to the dot, beginning to the dot, and to rank the distance traveled for each. So to do this ranking task, you always have to evaluate the individual graphs first. So we need to evaluate and determine the distance traveled for each of the individual six graphs. Then we can do the rank. The only axis on this graph that will help us with distance is the position axis, which is the, if you think in terms of math, the y-axis. So we need to look at the y-axis or the position axis on each of these graphs to determine how far you moved on the position axis. Okay, so when we look at graph A, you start right here, and which is -1, and you're going to travel from a position of -1 up to 0, because at the dot you're at position 0. So you traveled from -1 to 0. That means you traveled a distance of 1 block. Notice distance does not have direction, so it's not +1 or -1, it's just 1 block. You moved 1 block total along your journey. So we go to the second one, and you start at a position of 0, and you travel up to a position of 1.5, where the dot is. So you've traveled up 1.5 dots. We come to C, you start here, and you travel down 2 dots. 2 blocks rather. You come to D, you start here, and you travel down it's about 1.25 blocks. 1.25 because if this is -1 and this is -2, half of that would be -1.5, and this looks like half of the half. So 1.25. So you traveled 1.25 meters, or sorry, blocks. We don't have units. For E, you started at a position of -1 and you traveled up to a position of -0.25. So that's a difference of 0.75 blocks. And then E from here to here on the position line axis is 0.25 blocks. So now that I've determined the distance of each of the 6 graphs, I can then rank them from the biggest number to the smallest number. 2 is obviously the biggest number here. 0.25 is the smallest number, and so you're going to go in order C to B to D to A to E to F. And that is the rank for the distance. Now, if you got the same graphs, but you were now asked to rank displacement from most negative to most positive, the only axis, again, that will help us with displacement is the position axis. So because of that, you see that we will say we start here at -1, we go up to 1. So it's still, this object is only moving in one direction. So the number for distance and displacement is still the same. This starts here, it ends here. So that is a difference of 1 block. And so we would say that the displacement is 1 block, but we can't just say 1 block. Displacement has direction, so we would need to say +1 block. All right, so we do the same analysis with the other ones. So instead of 1.5 blocks, it's +1.5 blocks. This is displacing downward, so it's -2 blocks. D is also displacing downward, -1.25 blocks. E is displacing upwards, +0.7 blocks. F is displacing downward, -0.25 blocks. And with these rankings, we're going to now rank the displacements from the most negative to the most positive. So the most negative is -2 blocks, so that's C. And then we go to D, and so on and so forth, and we get our rankings: C, D, F, E, A, B.